third year student. This is Devaksha from LG Institute of Engineering and Technology under the LG University. So today we are going to talk about the shift registers, where earlier we have discussed about the combinational logic circuits. Then we have discussed about the sequential logic circuit, where we learn about the construction of flip-flop, how the flip-flop is behaving. After that, we learn about the counter design. Now, in a way, we have to design a memory. So one flip-flop can have the capability to store the one bit of information. If we want to extend this one bit, let's say in a number of 4 bits, maybe in a 8 bits, 16 bit, 32 bit, 64 bit, likewise, we have to design registers. That's one part. Once the data is going to be transferred from one device to another device, we require a kind of memory or a kind of shift register. So today we are going to talk about shift register. So if we talk about first the concept of shift register, where you can see here the flip-flop is a 1-bit memory cell which can be used for storing the digital data to increase the storage capacity in terms of the number of bits like 4, 8, 16, 32, 64. We have to use a group of flip-flops in such a way that flip-flop is known as the register. So here the shift register is a type of digital circuit using a cascade of flip-flops where the output of one flip-flop is connected to the input of the next. So here we have to connect the flip-flops in a series to make shift registers. So they share a single clock signal which causes the data stored in a system to shift from one location to the next location. So you can see here in this particular diagram where there is a D flip-flops are connected of 4 stages. So here you are going to apply 1010 signal, then that input is like a serial input and you are taking the output is a serial output. So once you are applying 0 here, when the clock comes, see this 0 will be shifted to the next stage, right? Same way here you apply 1 and at the second clock signal, see the 1 will be shifted to the next stage. That means the second stage. So earlier, the previous output 0 that would be again shifted to the third stage. Likewise, you can apply 1010 and after 4 clock signal, see all the bits 1010 will be shifted to the output, right? So this is how the shift register is going to be worked. So here the binary data in a register can be moved within a register from one flip-flop to another. The registers that allow such data transfer are called the shift registers, right? So there are 4 mode of operations like serial in, serial output, serial input, parallel output, parallel input, serial output, and parallel input, parallel output. That means you can apply a data input serially. You can take the data serially. That's what the serial in, serial output. Same way, if you apply this serially data and you are taking the output parallel, so that is what serial in, parallel out. Likewise, you have a universal parallel in, parallel out type of register ring counters, and based on that, if we want to discuss about the data transfer in a digital shift register, you can see there is a formation of terminology of data transfer. If I talk about the serial in, serial out, you can see the data is in and 1 bit of information after the application of each clock signal, see the 1 bit is going to be transferred from one stage to another stage. Now one stage is made up of the flip-flop, maybe it's a D flip-flop where data is going to be shifted when each clock pulse is going to be applied, right? So if there are 4 bits of information, that means if you apply 4 clock cycles, see likewise the all bit will be shifted successively during each clock cycle, right? So this is what the formation of data and how the data is going to be transferred in a digital shift register. You can see the data in serially and as well as data out is serially, right? If you talk about the serial in, parallel out, once the data you are applying serially and you are taking data parallel, you can see the 1 bit is going to be parallelly here serially shifted as well as you can take the output parallelly after the application of each clock. Same way, you can see there is a Parallel in serial out, where the data is applied or feeding parallelly, you are taking the data serially, right? So 1010 information you can apply parallelly, but after each clock cycle, the one bit of information will be shifted, right? Same way, you can see here parallel in parallel out. So data you apply parallelly, you can take the data parallelly out. So that's what the formation of data transfer. There are four types where you can shift this particular bits, right? So same way here, you can seek the data in a right position, as well as you can also seek the data in a left position. So in a sense, that is also called a shift left register or shift right register, right? Now based on that, we have learned about the application of clock in a digital shift register. You can see there is a D flip-flop, and after the application, each clock cycle, see how the data is going to be shifted. So you can see there is a data in. So this is a flip-flop 0, flip-flop 1, flip-flop 2, flip-flop 3, and you apply the first bit of data, which is bit, let's say 0, and you apply the clock signal. This 0 will be shifted here. Earlier there was a 0, right? Then you apply 1. If the second clock comes, see this 1 will be shifted here, and that previous 0 will be shifted to the next stage. Likewise, once you apply in a third clock, bit 0 you apply. So see, the 1 will be shifted to second stage, the previous 0 will be shifted to third stage, and the present 0 will be shifted to next stage. After the application of 4 clock, you can see that your data is 1 0. When you apply 1, so 1 0 1 0, that would be shifted after the 4 clock cycle. So after clock 4, the 4 bit data is completely stored in a register. So that's how the data will be stored in the shift register, as well as data can be shifted after the application of each clock, right? Same way here, types of different register you can see. There are 5 types of register: shift right register, shift left register, bidirectional shift registers, right and left both, circular shift registers, the in a ring, and linear feedback shift registers, right? What are the different application of shift registers? We'll discuss one by one. The shift register are used for temporary data storage. The shift registers are also used for data transfer and data manipulation. The serial in, serial out, parallel in, parallel out shift registers are used to produce time delay in a digital circuit. So like in your smartwatch, if you have you can generate a kind of delay, or you can switch on the timer. See, this is nothing but the function of shift registers, right? The serial in, parallel out shift register used to convert serial data into the parallel data. So you can also convert your flow of information from serially to parallelly, as well as from parallelly to serially, right? Thus, they are used in communication lines where the demultiplications of data line into a several parallel line is required. The parallel in, serial out shift registers used to convert parallel data to serial data, right? There are 2 bit of shift register. You can see the 2 bit of shift register. You can connect 2 flip flops in a chain, and now we can able to shift the stored value to the chain, right? So that is the basic information is same as you apply the clock signal. After 2 clock signal, the data would be shifted. So that's just 2 bit shift register. You can see the design. Based on that, if you buy the component from market, and you can implement that particular shift register on a breadboard, right? So based on that, you can have a 4 bit shift register where you can have 4 stages, and after 4 stages, you can see that there is a clock signal that is applying to each D flip flop, each stage of the D flip flop, and this is like serial in, serial out. So you can say different kinds of 4 bit shift register. You can see serial in, serial out, that is a 4 bit CISO. 4 bit serial in, parallel out, you apply the data serially and you can take it parallelly. Same way, after each clock cycle, see how the 1 will be shifted from first stage to the second stage, second to third, and third to fourth. So based on that, you can see this timing diagram. When first clock comes, the first data will be shifted as a part of the key, as a part of the QA. So this is the first stage output. Second clock, the 1 will be shifted to second stage. Third clock, the 1 will be shifted to third stage, and fourth clock, the 1 will be shifted to the fourth stage. Likewise, the data will be transferred, or data will be shifted, right? So 4 bit parallel in, parallel out shift register, you can see the data you apply parallelly in serial out. So data you can apply parallelly, and you can take the data serially. This is parallel in, parallel out. See both the kind of information you can see here.
If you want to design kind of universal 4-bit shift register where this particular design is can be working as a serial in, serial out, serial in, parallel out, parallel in, parallel out, and parallel in, serial out, that can be also possible, right? So from this mode of control, see, it's a simple design with the two AND gate and one OR gate. See, you can take the kind of you can design a kind of universal 4-bit shift register. Now this is a kind of shift left or shift right based on that mode of the operation of M. If you are going to apply M is equal to 1, let's say the data is shifted in a right direction. Same way, if you take M is equal to 0, right? M is equal to 0, the data is again shifted to the left position. So by that way, you can also design a universal 4-bit register just by introducing the control signal as a mode of the control signal in this particular universal 4-bit shift register, right? So this is all about the kind of shift register. So in summary, shift register is just shifting the data serially or parallelly, right, as per the design, as well as if you want to shift the data in the right direction. So if you want to shift the data in the right direction or maybe in the left direction, you can add more control signals and you can operate it, right? So this particular universal shift register chips are available. You just define the control word, control bits, and you can have both the operations like shift to right, shift to left, and or even in a parallel mode. So if you are going to apply S0 and S1 as 00, you hold this particular term. If you apply 0 and 1, shift to right. If you apply 1 and 0, shift to left. And if you apply 1 1, shift to parallel mode. Right? You can design a shift register and you can close this shift register with universal like shift right, as well as serial shift out, serial out, parallel serial out, parallel out. Thank you very much.